Lubin. Um, a homeowner is making plans to landscape her yard. She plans to hire professionals to install grass sod in some parts of the yard and flower beds in the other part. Grass sod installation costs $2 per square foot and flower bed installation costs $12 per square foot. Her budget for the project is $3,000. So first thing you have to make an equation. What equations need to have? An equal sign. Equations need to have an equal sign. That's what our last unit was all about. So that should be something that even if you didn't read it, even if you don't listen to me read it right now, you should be able to do. Typically, whatever paragraph of information they give you, you have to read a few times. Once just to see what's going on. Second to see what you're trying to figure out, the information for what you're trying to figure out. And then third to see if it makes sense. So table 5, whether it's on the spot or something you already wrote down, what is an equation that represents the square feet of grass sod X and the square feet of flower bed Y that she could afford if she used her entire budget? All right, so if you didn't hear that, I'm writing it down. All right, class, is that an equation? Does it use the variables they said to use? And does it make sense? Yes. So it was X was for the grass sod, and that costs $2 per square foot. Anytime it's like per, each, every, that implies what math? So we're paying attention to me. Again, I'll repeat it. Per, each, every, what math does that imply? Okay, multiplication. Really wish more than 2 people put it out there, but it should be fluent by now. You should be fluent in knowing what these words tell you to do, at least what math we do. However many square feet they buy, they're gonna have to multiply by 2 because that's how much it costs per square foot. And then same with the flower beds. They're listing that as Y, and it costs $12 per square foot. For budget, the total should be alone on one side, and what contributes to it should be on the other side. Now, you on the coordinate plane need to sketch a graph that represents your equation. So if you're having to graph by hand, what form would you want it in? Table 6, can you tell me? For graphing by hand, is that in the right form? What form would we like it to be? And class, how do you know when it's in that form? What's the key giveaway? When the Y is isolated. So on Friday's examples, it may not have looked exactly like Y equals mx plus b, but like maybe there was a 0 for the slope, so that was just the x term and things like that. If the Y is isolated, it's technically slope-intercept form. So you know it's in slope-intercept form when the Y is isolated. Table 7, what's going to be the first step in isolating the Y? Okay, good. So this is all review from last unit. I hope that we all got this far. On this right-hand side, are these like terms? Okay, no, again, I'm asking all of you. If you need here with one person, we shouldn't wait to pay attention until we're called on. Like, very easy questions I'm asking. Are these 2 numbers like terms? No. One has an X, the other one doesn't. You could leave it as 3,000 minus 2x. I like writing the X term first. But so long as you know what's going to be your slope and y-intercept later, it doesn't really matter. Okay, the 2x is still negative the way I wrote it, and 3,000 is still positive. Table 8, what do I have to do now to fully isolate the y?
So transfer.
Would that cancel it out? What is the 12 doing to the y right now? So subtracting is the opposite of that. What's opposite of multiplying? So that's what we need to do. And we need to do it to the other side. When we do it to the other side, we usually have to simplify. So that's why we separate it like this to each term. So that we can simplify here. So then table 9, what's my slope going to end up being? If this is my fraction I'm simplifying, my slope is close, -1/6. So we have the smaller number on top, like we're gonna say. But yeah, if you're not good with simplifying your fractions, your calculators can do that for you. But that is going to be my slope, -1/6. And then table 1, what's going to be my y-intercept? Okay. Okay, great. So now it's in slope intercept form. This is something that I can graph by hand, which you are having to do for yourself. So if you didn't get this far, I mean, you will see it again, it's just upcoming tests. It'll just be an inequality instead of an equation. But this is kind of preparing me for that. A lot of the steps are the same. So if you haven't graphed it yet, take a moment. Start trying to graph it, maybe do it in pencil. Okay, so for the graphing, what do we usually plot first? And my y-intercept is what again? So that should be where you started. Now, if you, from your y-intercept, went down a tick mark to the right 6, you technically can't do that on this one because the tick marks are not labeled the same. Okay, so like on my y-axis, what is each individual line representing? 25. Are they counting my 25s on the bottom as well? No, they're counting by 100s. So you can't just go from your y-intercept down 1 to the right 6. It's also really hard because these numbers are big. So what I would recommend is either pull it up in Desmos, see what you need to see on it, see some points that you can see without having to estimate, but also you can graph using your other intercept, your x-intercept. So just kind of hold on that. It'll come naturally when we get there. But for right now, you should for sure have your y-intercept plotted. If I were to truly go down 1 to the right 6, then I'd also have a point at 249 for the y and 6 for the x. Because that would be me literally going down 1 to the right 6, like those values. So this one would be on the line. The next one that would be on the line, going down another 1 will affect me y, and to the right another 6. Here's just 2 examples of some that are on the graph. It's hard to graph them when they're so close, but I'm telling you these 2 points are on the line. We are going to, in the next one, just kind of write these down next to it, saying that these will be on the graph. Because in the next part of the activity, you have some bullet points. It says, in this situation, what does a point on the line mean? You could use like one of these 2 as your point on the line, as an example. And when I ask you, what do they mean? Well, related back to the real world situation. 6 what? 249 what? Like, go back and reread it and be able to tell me what this means. Then you have a couple other bullet points that say, what does the vertical intercept tell us? And what does the horizontal intercept tell us? So come up with like a sentence for each. We'll review them in about 3 minutes. So we're interpreting it in relation to the real world situation. Any questions right now? So you're answering these bullet points that are under your warm-up. We're going to go over them in 3 minutes. Figure it out. So table 2, what would a point that's on the line tell us? In this situation, what are they talking about? Okay, the y and the x. What is, like, say, the x represent? So it does explicitly say in some of the words in our problem, but it's even easier because they gave us a graph with the axes labeled. So like if you read the x-axis, and this is a great strategy, so you're all paying attention. If they give you a graph, that's even better than having to reread the paragraph, because the x, what it represents, should be on your x-axis. So what does it say on the x-axis? Grass sod in square feet. So if I have a point on the line, like maybe one of these two, we can use as an example. This coordinate that's on the line, when I relate it back to the real world situation, that 6 is 6 square feet of grass sod that you guys. That 249, that y value, read what it says on the y-axis. What does it say on the y-axis? The square feet of flower beds. So relating it back to the real world situation, this is how much of each that she can buy that uses her entire budget. Remember, that's what we made the equation for. And she uses her entire budget. You find, for example, 6 square feet of grass sod and 249 square feet of flower beds. And that goes for any point that's on the line. So any point that is on the line meets the criteria. Okay, it's just different combinations. So she could also use her whole budget and buy 12. What is the 12? All of you? Yeah, 12 square feet of grass sod and 248 of. So whatever random situation it is, hamburgers, hot dogs, reread it. What do they want the X to be? The hamburgers or the hot dogs? Be able to say, if X is this, then this is what it represents. That's really the gist of the whole lesson. Okay. So if it's on the line, it meets the criteria, and it's just one of the many combinations that are out there. Okay. Now, for what does the vertical intercept mean? Vertical is just another way to say y-axis, right? So looking at our y-axis, we were able to at least plot that one. Table 3, can you tell me what my vertical intercept tells us? Okay, so how many square feet of flower beds she can buy when what happens? So there's another number with that vertical intercept. It's 0,250 for the coordinate. So 0 what? So this tells us that she can buy 250 square feet of the flower beds when she buys no grass. You can write that wherever, maybe under the bullet point is probably better than on the graph. I'm just trying to show you. This is where the grass sod is 0. This is the most flower beds she could buy. That makes sense? Good? We've done this before, like when we talked about how many rides can they go on at the amusement park if they play 0 games, right? These are your intercepts that you have. So even though we haven't found yet the horizontal intercept, because it's kind of a funky graph right now, we know that wherever it is, how many flower beds would they be buying? 0 at my horizontal intercept. So if I take my given equation, which I'll write it down here because I'm a little out of room. Here is the equation that we made. 2x plus 12y equals 3,000. If I want to find my horizontal intercept, I need to make the flower beds 0. Because by definition, your horizontal intercept, your x-intercept, is when y is 0. All right, I don't know if that is working attention, if that's making sense. But in first hour, I literally had to ask my students, like at this coordinate, the x is 200, the y is 0. At this other coordinate, the x is 800, the y is 0. So everywhere at the x-axis, the y's are 0. So that's how I can solve it, and that's how I can actually graph it, which we weren't able to really do earlier. Questions on that? Okay. So then anything times 0 is what? So that basically cancels out this term and just makes it 2x equal to 3,000. Opposite of multiplying by 2 is, and that's what we're going to do on each side. So when they buy no flower beds, this is how many square feet, that's meant by this is how many square feet of the grass sod they So now you can graph that on your graph. Your x-intercept is 1,500. Questions on that? So plot that. Now you should be able to connect your two intercepts and be able to graph. So my x-intercept is here. Try to make a straight line through them. And then maybe you then could use that to find other points that are on. But it's hard when the tick marks are not counting those things. All right, but any questions on that? So as kind of like a cool down, if you will, because it's a short day and I'm not spending more than 1 day on this. I really do think if you do your practice that you'll get it. It's all about just interpreting your coordinate. So like you have this slightly different situation now underneath it. So now she's considering using more low-cost materials. They graphed it for you already. Be able to answer the questions about what these coordinates mean, given this new, slightly different situation. So you're answering each part. What does the point 500, 100 mean? Write an equation that is represented by the graph. What do the solutions need in the situation? You ready to talk about it in 2 minutes? Brayden? No, it's too late, sorry. Okay,
Table 4, can you tell me what the 500, 100 means in this situation?
Okay, so which one specifically is for the gravel? Okay, good. So I didn't read you the paragraph, but you could read it yourself. It does give you the graph, so you can read like the x-axis. They use this in place of the x. That means that that is 500 square feet of gravel. So square feet of gravel. The 100 is my square feet of, read the y-axis. The artificial turf. Abbreviating. But just read what's going on. This is in the x spot, read the x-axis. This is in the y spot, read the y-axis. And since they are on the line, they meet the criteria for that situation. So that means if she buys this amount of each, she's going to use her entire budget. Okay? That's basically the difference. As far as the equation goes, you could have put it in slope-intercept form, or you could have used your x and y intercepts. Up to you. If you did it in slope-intercept form, what's my y-intercept? So then the 200 would be the constant. And there's slope, you just need two areas that you can see really clearly without having an estimate. Going from like here to what they have on here, I'm going down 300 and to the right 100. So it looks like they're not, no, sorry. I'm going to the right side. So then your slope then is negative 3. All right. Do your practice, I recommend we're not spending more than today. So hopefully you got some.